In this video, we are going to talk about how to find the greatest common factor and the least common multiple. So first of all, let's look at the difference between factor and multiple. In the previous videos, we have talked about the word factor. So when it is used as a noun, it means a number that can go into other numbers. For example, we have three numbers here, 2, 6, and 30. And notice that 2 can go into 6, and 6 can go into 30. And of course, 2 can also go into 30. So in this case, we will call 2 a factor of 6 and 6 a factor of 30. And also we can also call 2 a factor of 30. So again, factor is like a part. It's smaller. It can go into another bigger number, or at least the same number. For example, 2 can also go into 2, 6 can go into 6, 30 can go into 30. So in general, factors are smaller, except itself. But multiple is the other way around. For example, we can say 6 is a multiple of 2. So when we switch the number 2 and 6, and we will call the bigger number 6 a multiple of 2. And for the reason because we can multiply 2 to get 6. So multiple comes from the word multiply. Same thing for 30, we say 30 is a multiple of 6 because when we multiply 6 by 5, we get 30. So 30 is a multiple of 6. So we need to make sure we know the difference between them. Factor is usually like a part containing another number. For example, 2 is containing 6, and 6 is containing 30. But multiple is usually bigger. 6 contains 2, and 30 contains 6. So now let's look at how we found the greatest common factor and the least common multiple. Usually, the least, so we're going to start with the least common multiple. Usually we call it LCM. And when we have two numbers, both of them have multiples. But we want to find, but their multiples might be different. But we want to find a common multiple, and specifically the smallest, because they may have many, many common multiples. So here is an example. So if we want to find the least common multiple of 6 and 8, there are two ways we can do in general. Now, for smaller numbers like 6 and 8, we could just make a list. By the way, M here means multiple. So we just talked about the definition of multiple. So multiple is when you take the number and multiply by 1, 2, 3, 4, and any integer, we call it a multiple. So let's take, so we're going to start with solution 1 to list all multiples and then search for a common one. And in a second, we're going to talk about solution 2. We can use prime factorization, which was discussed in previous 2 videos. So first, what we do is we make a list of all the multiples of 6. Well, not all of them, the first few, because we have, for each number, we have infinitely many multiples. All we have to do, so again, multiple comes from the word multiply. So when we take the number 6 and we multiply by 1, any number times 1 is itself, so we get 6. But if we multiply by 2, 6 times 2 is 12. We got another multiple. And when we multiply 6 by 3, we get 18. It's another multiple. And we can take 6 multiplied by 4, we get 24. And I stopped at 24, but you can continue, multiply by 5 to get 30, and continue, and you may get as many as you want. Similarly, we're going to take 8, multiply by 1. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And the reason I stopped is because now we found a common one, and both of them have 24 as a multiple. Notice that they have different multiples, but they also have some common ones. And 24 is the first common one we can see from the list. But if you continue the list, you may be able to find more, like for example 48, because 6 times 8 is 48. 8 times 6 is 48. But 48 is bigger than 24. It's not the smallest. So notice that we're trying to find the least, which means the smallest, the lowest, the smallest. And in this case, it's 24. So this is how we find it, by making a list of all the multiples and try to find a common one. This method works well when we have smaller numbers, but if we have big numbers, this method can be very tedious. I will show you an example later. Solution 2 is to use prime factorization, which is to break down both numbers to see what kind of prime factors are contained in them. So first we're going to break down 6 as 2 times 3. And next we break down 8 as 2 times 2 times 2. Again, if you forgot how to do prime factorization, make sure you go back to the previous 2 videos. So now what we do is this is what we try to do. Notice that I put a 3 far behind this 2. It's because I want to line up in the same column, I want to line up the same number. So the reason I did not put this 3 right after 2 is because, so let me see, if I put that 3 here, in the second column, there are 2 different numbers. One of them is 3, the other is 2. And this is fine if you understand how to search for the common multiple. But it would be easier if we move this 3 in and create a new column for that 3. That way we don't put different numbers in the same column. So this way, if you can see, the first column only 2's, second column only a 2, and third column only a 2, and the fourth column only a 3. But if you have the same numbers, and make sure you will put them in the same column. And for example, this 2, I have to put in the first column. We're not going to create another column, because first rule is to try to line up as all the same prime numbers as much as possible. So after we factor both numbers, get all the prime numbers, and line up the same prime numbers, what we do is we're going to bring down one number from each column. So as you can see here, in the first column we have 2 2's. The second column we only have 1 2, and 1 2 here, 1 3 there. But it doesn't matter how many 2's or 3's you see in each column. You're only going to bring down one number from each column. So this is what we do. First column 2, second column 2, third column 2, and the fourth column 3. So again, bring down one number. Doesn't matter how many numbers you see in that column. Now, after you bring down those numbers, you can multiply them all together, and you can see 2 times 2 times 2 is 8. 8 times 3 is 24. So we get the same answer. Now, for the smaller numbers, the first solution might seem easier, but for big numbers, the second solution is going to be easier. And also, we can use the same method, solution 2, to find the greatest common factor. But if you do the first solution, you have to make different lists for multiples and factors. However, the second method not only can be used to find the least common multiple, but also can be used to find the greatest common factor. So we will explain in the next video. And notice that this method, solution 2, why does it work? And LCM, the focus is the word M. M is multiple, coming from the word multiply. So we want to, the LCM is a number that contains 6 and contains 8. So remember, multiples are usually generally bigger than both numbers. Factors are generally smaller. And so 24, we want to find a number that contains 6 and contains 8. But it might be a little difficult. Some of you might be able to see 24 immediately. But for big numbers, it's actually going to be difficult to see. So the idea is we can break down both numbers to see what each of they contain. For example, 6 contains 2 and 3. 8 contains 2, 2, 2, right? So you want to find a number that contains both 6 and both 8, which contain, among these two, 6 contains 2 and 3, which means the answer we found we're going to get also should contain 2 and 3. And the answer we must contain 8, which means the answer must contain 2 and 2 and 2. So that's why we break them down to get those smaller numbers and try to see, to find the numbers which numbers are contained in 6 and 8. That way we can pick those numbers and multiply them to get a number that can be contained in the answer 24. So this way you can see that 24, this 24, where we got it. We got it from multiplying 2, 2, 2, 3. And where do these numbers come from? 2, 2, 2, 3. And this 2 comes from this 2, these two 2's. And this 3 represents that 3. And so when these two highlighted, 2 and 3, when we multiply them, we get 6. And which is contained in 24. And similarly, the first 2 and the second 2 and the third 2, when we multiply them together, we get 8. So that tells us 8 is contained in 24. So the first 3 2's give us 8, which is part of 24. And the first 2 and the last 3, we multiply them to get 6, and that is also contained in 24. So that way we guarantee 6 and 8 are both contained in 24. So that makes 24 a common multiple of both 6 and 8. And also this is going to be the smallest, because 24 contains all the factors but nothing else. 24 contains all the factors of 6 and 8, but nothing extra. So which guarantees 24 is the smallest common multiple.